Hi there. For this video, we'll be learning about perpendicular lines. So perpendicular lines are lines that intersect one another or cross one another at a 90-degree angle or right angle. So we usually see this in figures such as triangle and squares. Take note that if we extend these lines, then these two lines out here are perpendicular lines since they cross or intersect one another at a 90-degree angle. So what is special about these lines? Well, let's try to observe these lines through their equations. Observe that these two equations are already in their slope-intercept form. So we know that these are their slopes. -1/2 and 2. Let's try to denote 2 as m1 and -1/2 as m2. So we have here m1 to be equal to 2 and m2 to be equal to -1/2. Now, take note that m1 times m2 will give us 2 times -1/2, or simply -1. Take note of this one. Moreover, take note that to get 2 to 1/2, we simply get the negative reciprocal of 2. Indeed, 2 getting its reciprocal will give us 1/2. Taking the negative will give us -1. This out here is m2. This here is m2. And these are the two things that are really nice about perpendicular lines. In fact, this actually applies to every perpendicular line. So we'll try to generalize this idea in the next remark. So we say that two lines, say L1, and it is given by y equals m1 x plus b1, and L2, say y equals m2 x plus b2. So I just wrote these lines in their slope-intercept form. We say that these are perpendicular if first their product is equal to -1, or m1 is equal to -1/m2, or basically the slope of one of the lines is the negative reciprocal of the slope of the other. So let's try to explain how we arrived with this through an illustration. So we consider this line out here given by y equals mx. So basically, this is a line that passes through the origin since normally the equation of the line in slope-intercept form has a plus b out here. But since we remove that, then we assume b to be 0. So we know that the y-intercept is 0, or it passes through the origin. So we consider this line out here. And take note that let's write another Cartesian plane out here. We know that this one out here represents the positive x-axis. This here represents the positive y-axis. The negative x-axis is here, and the negative y-axis is here. Now, since we want to rotate the line in 90 degrees, take note that the Cartesian plane has a 90 degree out here. So our goal is to rotate this to obtain a perpendicular line. Since we have here y and x, we rotate that by 90 degrees. So x out here rotates to y, and y out here rotates to negative x. So by doing that, this equation becomes y becomes negative x equals m, and x becomes y. And let's try to write this in its slope-intercept form. So what we do is we simply divide m both sides to obtain y equals negative 1 over m x. So this one is already in its slope-intercept form. Now if you try to observe their slopes, we have here m and negative 1 over m. So clearly, the slope of this line that is rotated 90 degrees is negative reciprocal, which matches what we want. And when you multiply m and negative 1 over m, we obtain negative 1, which again matches our desired outcome. So again, what you need to remember in here is this. And since we have an or here, you may only need to choose one of these to prove that two lines are perpendicular. So let's try to understand and learn more about this through an example. So in here, our goal is to determine if these two lines are perpendicular. So we have x minus y equals 3 and x plus y equals 7. Now feel free to pause this video so that you can try this example on your own. Good, let's now start. So again, to determine if these are perpendicular, we either show that m sub 1 times m sub 2 is equal to negative 1, or m sub 1 is equal to negative 1 over m sub 2. Note that you can interchange m sub 1 and m sub 2 out here. It doesn't matter. So, starting with this first line out here, we have x minus y equals 3. Since our goal is to determine the slope, what we can do is we can write this in its slope-intercept form. So take note that we can subtract x both sides to obtain negative y equals negative x plus 3. Multiply negative 1 both sides, and this gives us y equals x minus 3. So, clearly, the slope out here is 1. Let's go on to the next one. So we have here x plus y equals 7. we subtract x both sides to obtain y equals negative x plus 7. So now that it is in the slope-intercept form, we take note that since there is a negative here and there is no number out here, or there isn't a number out here rather, then we know that this must be negative 1. So the second slope is given by negative 1. Given these two, let's try to check if the conditions for perpendicular is true. But again, you only need to choose one of these two. But I'll showcase both of them so that you'll see that this is valid for both. So first we have here m sub 1 times m sub 2. We'll have here 1 times negative 1, which is negative 1. So this first condition is valid. Let's check the next one. We have here m sub 1 is equal to negative 1 over m sub 2, which is negative 1. Then we can cancel out the negatives out here to obtain 1, which is correct since it matches what we got. So indeed, we can conclude that these two lines, L1 and L2, are perpendicular. So as simple as that. Just checking the slopes and considering our remark from the previous one. As a proof that this is correct, here's a graph that showcases the two lines that we have. Clearly, we have a 90-degree angle here, or right angle. So these two lines are indeed perpendicular. Now that we know how to determine if an equation of a line is perpendicular, we now try a nice application of it through this example. So in here, our goal is to determine the equation of line perpendicular to y equals 5x minus 3 that passes through the point 5, 2. So before I show the solution, feel free to pause this video so you may try this one on your own and you may just play it back if you already have an answer or if you are stuck in the middle. So let's start. So since we are given a line already and it is in its slope-intercept form, then we know that the slope of this line is 5. So to find an equation that is parallel, or rather perpendicular to this line, what we do is we use the second option, which is take the negative reciprocal. So from 5, taking its negative reciprocal, we'll have here, take its reciprocal, so we have 1 over 5, then get the negative of this, we have negative 1 over 5. So this is the slope of the line perpendicular to y equals 5x minus 3. So what we have so far is y equals negative 1 over 5 x plus b if it is in the slope-intercept form. Our only problem is finding b, but fortunately we are given the points, or the point 5, 2. So we simply plug this into our equation. So we'll have here, plugging in y, which is 2, this one is equal to negative 1 over 5 times x is 5 plus b. So the 5 here cancels out and we obtain 2 equals negative 1 plus b. Then we add 1 both sides to obtain b equals 3. So we plug this in back to our equation to obtain y equals negative 1 over 5 x plus 3. This out here is the answer to this problem. To show that this is correct, here's a graph showcasing the two lines that we have. So y equals 5x minus 3 is the given, and y equals negative 1 over 5x plus 3 is the line that we got. So clearly, these two lines are perpendicular. Moreover, the equation of the line that we got clearly passes through the point 5, 2. So we got the correct answer for that problem. So I hope you got this one as well. To end this, here's an exercise that you can work on. So our goal here is to determine the equation of the line perpendicular to 4x minus 3y equals 0 passing through the origin. So to answer this, the way or the solution is similar to our second example a while ago, but this time we're given a line that is in the standard form. So what you'll be doing is you'll be first converting this to its slope-intercept form so that you can get the slope easily. Moreover, we aren't given the exact point, we are just told that it passes through the origin. But take note that when we say that a line passes through the origin, that simply means that it passes through the point 0, 0. So these are the tools that you'll be needing in order to solve this problem. So that's it. I hope you enjoyed this one. Feel free to comment down below your answer to this item, as well as any comments, recommendations, and suggestions that you have for our future videos. So that's it, and that is all for this video.